The geographer's aim is to study the surface of the earth as the home of man. Anything that occurs on the surface of the earth is the subject matter of geography. The subject of the interior of the earth belongs to the discipline of geophysics. As a student of geography, the basic question which arises here is that why the geographers should study the interior of the earth. The earth's surface is dynamic in nature and is undergoing transformations, some of which are slow and some are very sudden. The processes which have origin inside the earth are called as endogenetic processes. The main driving force for these geomorphic activities lies in the interior of the earth. These geomorphic processes which have origin in the interior of the earth is responsible for the evolution of various continental and oceanic landforms on the surface of the earth. Besides, mountain building activity, which is caused due to folding, faulting, wrapping of the earth's crust, is due to the forces that are located in the interior of the earth. It is therefore very essential for the student of geography to have some basic knowledge about the interior of the earth. With this background, the basic aim of this lesson is to understand different views on the internal structure of the earth. Based on seismic data and other sources of information, the earth is divided into layers. Each of these layers has different physical and chemical composition. Different layers of the interior of the earth are identified by various scientists such as Suez, Daly, Holmes, van der Graat, etc. Based on the chemical composition, Suez has identified 3 zones. Suez classified these layers as Sial, Sima and Nife. Based on the chemical composition, this layer is dominated by silica and aluminium and therefore termed as Sial. This layer is dominated by silicates of potassium, sodium and aluminium. The continents are mostly formed by Sialic layer. The thickness of this layer varies between 50 to 300 kilometers. This layer is mainly composed of granites. This is the second layer which is located below the Sialic layer. This is the middle layer. This layer surrounds the core of the earth on all the sides. This layer is mostly made up of silica and magnesium and therefore called as Sima. The silicates of magnesium, calcium and iron are most abundantly found in this layer. This layer is composed mainly of basaltic rocks formed due to cooling and solidification of magma during volcanic eruption. The thickness of this layer varies between 1000 kilometers to 2000 kilometers. This is the third layer, or this layer is the innermost layer and is located below Sima. The layer is composed of nickel that is Ni, and ferrous, that is Fe. It is made up of dense heavy metallic substances with predominance of nickel and iron. The diameter of this zone is 6880 kilometers. The presence of iron, that is ferrous, indicates magnetic properties of the Earth's interior. The layer is often called as core or metallic core. Based on the thickness and density and depth, Daly recognized 3 layers such as outer zone, which is composed of silicates. The average density of this layer is 3.0, thickness is 1600 kilometers. The intermediate layer, which is made up of mixture of iron and silicates. Average density is from 4.5 to 9 and the thickness is 1280 kilometers. The central zone is made up of iron and is in solid state. Average density is 11.6 and the diameter is 7040 kilometers. Arthur Holmes recognized 2 major layers in the earth. The upper layer is termed as crust, which is composed of whole of Suez Sialic layer and upper portion of Sima. The lower layer has been termed as substratum, which represents lower portion of Suez Sima. Holmes has determined the thickness of the Sial below the continental surface on the basis of thermal conditions, surface seismic waves, longitudinal waves and subsidence of deepest geosynclines. Van der Gracht has identified 4 layers based on the composition of the interior of the earth. The outer Sialic crust. The average thickness of this layer is 60 kilometers. The thickness of this layer is just 20 kilometers under continents. The density of this layer varies between 2.75 to 2.79. Intermediate layer or mantle. The thickness of this layer varies between 60 to 1140 kilometers, with average density varying between 3.1 to 4.75. Zone of mixed metals and silicates. The thickness of this layer ranges between 1140 kilometers to 2900 kilometers, with the average density ranging between 4.75 to 5.0. Metallic nucleus. This is the innermost layer with a thickness ranging between 2900 to 6371 kilometers. The average density of this layer is 11. The generalized pattern of the layering of the Earth's interior of the Earth, which was mostly accepted by majority of the scientists, is as follows. Lithosphere. It is the uppermost layer with a thickness of about 100 kilometers, is mostly composed of granites. The chemical composition is predominated by silica and aluminum. The second layer is pyrosphere. This layer is mostly composed of basaltic rocks. The thickness of this layer is 2780 kilometers, having an average density of 5.6. The third layer is barysphere. Barysphere is mostly made up of iron and nickel. Average density ranges between 8 to 11. In the last few decades, scientists have utilized a new analytical technique known as seismic tomography. This recent and the scientific technique promises to greatly enhance our knowledge of the Earth's interior. The seismic tomography is similar to computer assisted tomography, that is CAT, used in medical field. In seismic tomography, seismic waves are used like X-rays. Seismologists analyze the velocity of seismic waves as they pass through the earth in different directions. This technique provides images showing regions where seismic waves travel faster or slower than the normal. Seismic tomography can be used to outline the pattern of flow in the mantle. On the basis of the seismic waves and seismic tomography, it may be concluded that the earth has several density zones inside. The behavior of the seismic waves and the tomographic analysis proves beyond doubt that earth consists of three layers. The first layer is the crust, the second is the mantle, and the third is the core. The scientific study and the analysis of various aspects of seismic waves have enabled the scientists to unravel the mystery of the earth's interior. Based on the changes in the velocity of seismic waves while passing through the interior of the earth consists of three layers, which are as follows. The crust. It is the outermost solid part of the earth. This layer is synonymous with Sial. The thickness of the crust varies under oceanic and continental areas. Continental crust is thicker and compared to oceanic crust. The mean thickness of the continental crust is 30 kilometers, whereas that of the oceanic crust is around 5 kilometers only. The continental crust is thicker in the areas of major mountain system. It is as much as 70 kilometers thick in the Himalayan region. This layer constitutes less than 1% of the earth's total volume. Sedimentary rocks predominate in the upper part of earth's crust. The thickness of the sedimentary rocks is less than 32 kilometers, but in areas of fold mountain, this may increase to 32 kilometers or more. Below the sedimentary cover is a layer of crystalline rocks consisting of granite and gneisses in the upper section and basaltic rocks in the lower section. Basaltic rocks are mostly associated with the oceanic crust. On the basis of the change in the velocity of seismic waves, the crust is further divided into upper or outer crust and lower or the inner crust. These two layers are separated by a discontinuity. The velocity of P waves suddenly increases in the lower crust. The average velocity of P waves in the upper crust is 6.1 kilometer per second, while it increases to 6.9 kilometers per second in the lower crust. The lower limit of the crust is a discontinuity layer called as Mohorovic discontinuity or Moho layer. The second zone of the interior of the earth is mantle. The portion of the earth's interior beyond the crust is called as mantle. This layer is situated between the crust and the core of the earth. The mean density of mantle is 4.6 gram cubic centimeter grams. It extends up to a depth of 2,900 kilometers. The thickness of mantle is less than half the radius of the earth, but contains 83% of the total volume and 68% of the total mass of the earth. Mantle is mostly made up of silicates of rich in iron and magnesium. Mantle is divided into two zones on the basis of changes in the velocities of seismic waves and density as upper mantle or the asthenosphere and the lower mantle. The upper or the outer mantle or the zone of asthenosphere is the main source of magma that finds way into the surface during the volcanic eruption. The upper part of the asthenosphere is partially molten in condition. The velocity of earthquake waves decreases in the asthenosphere and therefore is referred to as low velocity zone. The lower mantle extends beyond asthenosphere in the form of solid state. The mantle and core boundary is called as Gutenberg discontinuity. Along Gutenberg discontinuity zone, there is pronounced change in the density from 5.5 cubic centimeter grams 10 cubic centimeter grams. This change is indicated by sudden increase in the velocity of P waves, that is 13.6 kilometers per second along the mountain core boundary or Gutenberg discontinuity. There is a pronounced change of density from 5.5 cubic centimeter grams to 10.0 cubic centimeter grams, Gutenberg discontinuity. The density further increases with decreasing depth. Mantle is comprised of various rocks. Outer mantle consists of rocks rich in minerals like olivine, pyroxenes, silica, etc. And the lower mantle consists of most of the iron related minerals. As per scientific observation, it is seen that the rocks melt in mantle due to high temperature. Mantle plays an important role in the Earth's dynamics and various tectonic activities. It directly or indirectly is associated with continental drift, plate tectonics, mountain building, etc. The energy and the material which is required for the earthquakes and volcanoes and sea floor spreading come from the mantle. The core of the earth is the innermost and the deepest zone of the earth. It extends from the lower boundary of the mantle at a depth of 2,900 kilometers to the center of the earth, that is 6371 kilometers. It appears that the density of the core of the earth is more than twice the density of mantle, but the volume and mass of the core is 16% and 32% of the total volume and mass of the earth respectively. Density of core ranges from 9.5 to 14.5 and sometimes even higher. The core is divided into outer core and the inner core. The dividing line brings at a depth of 5150 kilometers to the center of the earth. The S waves, which can pass through only the solid matter, suddenly disappears at a depth of 2900 kilometers. At this depth, the velocity of P waves, which can travel through the solid, liquid and gaseous materials, abruptly decreases from 13.7 kilometers per second to 8 kilometers per second. As the S waves cannot penetrate this region, it is assumed that the Earth's core is in liquid state. There has been identified as outer limit of the core. The core is made up of heavy material mostly constituted by nickel and iron. It is sometimes referred to as Nephe. To sum up, the velocities of P waves and S waves through the earth indicate that the earth has a solid inner core, a thick mantle, a soft asthenosphere and a rigid lithosphere. As a single medium cannot transmit waves of the same type like primary or secondary waves at different speeds, when two compressional waves or primary waves are received, separately at a station. The implication is that they must have been propagated in different media, that is wave channel. The discovery of these channels proved to be useful in the identification of transitional zones or discontinuities. Conrad discontinuity. The discontinuity zone is located between the upper crust and the lower crust. The upper crust is separated by a transitional zone, that is Conrad discontinuity, at a depth of 20 kilometers from the lower crust. Moho or Mohorovičić discontinuity. At the base of the lower crust, earthquake waves increases abruptly in velocity as they enter the denser zone. The mantle. This boundary is called as Moho discontinuity. Gutenberg's discontinuity. This transitional zone that defines the mantle core boundary, which is located at a depth of 2,900 kilometers. The views of the internal structure of the earth are not dependent upon any one evidence. Many views were presented to describe the internal structure of the earth. It appears that there are differences of opinion about the number of layers, thickness of the layers, and various physical and chemical properties associated with various layers that constituted the internal structure of the earth. The scientific study and the analysis of various aspects of seismic wave pattern enabled the scientists to unravel the mystery of the earth's interior. Based on the behavior of the seismic waves, it is concluded that interior of the earth consists of 3 layers of varying properties, identified mostly on the basis of velocity of seismic waves.